Here we go. Let's get ready. Let's take just a second. And the Elmo should start working here any second. We're flying through this review. We'll get it done here pretty quick. Here we go. Tell the asymptotes for the function. So our first asymptote is our vertical asymptote, which is that the denominator equals 0. Therefore, when x equals 4, that's a vertical asymptote. The other asymptote we have out there is a horizontal asymptote, also known as end behavior. We look at what matters most on top, which is x, over what matters most on bottom, which is x. That's going to approach 1. So y equals 1 is a horizontal asymptote. Done. Tell the asymptotes for this function. Sure. Factor out your denominator. We get x plus 2, x minus 2. At first glance, vertical asymptotes look like they're a negative 2 and a 2. However, looking at the top, we can see there's a 0 at x equals negative 2, which means negative 2 is not an asymptote. It actually is a hole. So there's going to be a hole in negative 2 something. Vertical asymptote is x equals 2. Our horizontal asymptote, or end behavior, is going to be x over x squared, which equals 1 over x, which that is going to go to 1 over infinity, which is going to 0. So y equals 0 is our horizontal asymptote. We're done. Tell the asymptotes for this function. Sure. On the top, we factor out. We get x minus 2, x minus 1. So the zeros are at x equals 2 and x equals 1. On the bottom, we have vertical asymptote at x equals 4, because that's when that denominator will be 0. Our horizontal asymptote would be x squared over x, which goes to x, which therefore goes to infinity, which tells us it's not a horizontal asymptote, but a slant or oblique asymptote. The way we find it is we do long division, 1, negative 3, 2, drop down the 1, 1 times 4 is 4, add negative 1, or positive 1 times 4 is 4, that's a 6. We don't care about the remainder, it's 1x plus 1, so y equals x plus 1 is our slant or oblique asymptote, and we're done. Says find vertical asymptotes, horizontal asymptotes, holes, x-intercept, y-intercept, domain, and range. So basically, let's do our 1, 2, 3. I would do the zeros first, which are going to be your x-intercepts. So I would take x squared minus 9, so it equals 0, hippo butt, x plus 3, x minus 3. We get x equals negative 3, and we get x equals 3. Denominator for the vertical asymptotes, I would get hippo butt, minus 2 minus 3. So I get x equals 2 and x equals 3. So right there, I can see I'm going to have a problem. So I have a vertical asymptote at 2. I'm going to have a hole at 3. The horizontal asymptote is going to be x squared over x squared, which is just going to 1, because x squared over x squared divides to 1. The x-intercepts, I now only have one x-intercept at negative 3, 0. The other one's a hole at 3. How can I determine where that hole exactly is? Well, I take the top in factored form, put it over the bottom that's in factored form. Now note, when I let x get really close to positive 3, when I let x get really close to positive 3, don't let it be 3, but get close. These two numbers right here are going to become exactly the same, so they divide to 1. Top number is going to get really close to 6. Bottom closing number is going to get really close to 1. So it approaches 3, 6. So there's our hole. Hole's at 3, 6. X-intercept is a negative 3, 0. Y-intercept, if I plug 0 in, I get negative 9 over 6. Or you could say that that's 0 and negative 3 halves. The domain. So my domain can be anything but where there's a break. And there's going to be a break at the vertical and then the hole. So it's going to go negative infinity up to 2, union with 2, to 3 union with 3 to infinity. The range also happens where there's a break, if it's a hole, and where there's a horizontal asymptote. The horizontal asymptote's at 1. The hole breaks at 6, so I'm going to go from negative infinity up to 1, unioned with 1 up to 6, unioned with 6 to infinity. And we're done. Graph this piecewise. Sure, graph it in pieces. If you need to, make 3 different t-charts for the 3 different pieces. So here's the first piece between negative 3 and 0. Negative 3, negative 2, negative 1, and 0. If I plug in negative 3 minus 1 is negative 4. Negative 4 times 2 is negative 8 plus 5, negative 3. Plug in a negative 2. Negative 2 minus 1 is negative 3. Negative 3 times 2 is negative 6 plus 5 is negative 1. Plug in a negative 1. Negative 1 minus 1 is negative 2 times 2 is negative 4 plus 5 is 1. Plug in a 0. 0 minus 1 is negative 1. Negative 1 times 2 is negative 2 plus 5 is 3. Now remember, at 0, 3, it's going to be an open circle. So a negative 3, closed circle, negative 2, negative 1, negative 1, 1, 0, open circle. So there's the first part graphed. Second part is just 4 from 0 to 3. So at 0 it is equal to, so at 0 it's 4 full dot, 1 full dot, 2 full dot, 3 open circle. Last we'll graph absolute value from 3, 4, 5 up to 6, absolute value of 3, 3, absolute value of 4, 4, 5, and 6. So at 3, I'm at 3, 4, 5, 6, open circle. Oh, 3, 4, 5, 6. Give yourselves another ticket. You're welcome. That baby's graphed. 43. Match them up. Sure. Match them up. So, you know, these two look very similar. Exponential growths. 10 is growing faster than 3. So 10 would be B. And 3 would be C. A log and a natural log are very, very similar. They're both going that way. Remember, so we have one that going to have a point at 1, 0, and then 2, 1. That's the log base 2. So that's log base 2. Then the natural log is going to have a point at 1, 0, and then 2.71. So it's going to look more like that. That's the natural log. So natural log is E, log is D. Now we need to determine, what do these guys do? Well, a negative on the inside is going to horizontally reflect that. So instead of being exponential growth, it's going to be, that's A. Negative on the outside, it's going to be a vertical reflection. So that means it's going to reflect down. That's got to be F. We're done. So A is K of X. B is H of X. C is G of X. D is J of X. E is M of X. And F is L of X. Okay. What solid is formed when a rectangle is rotated around one of its sides? That is going to be a cylinder. What solid is this rotated around parallel to one of its sides? Again, a cylinder. Calculator allowed. Table below shows the pass rates. What is the average rate of change? Average rate of change is a slope from 213 to 216. So from 213 to 216. So on the bottom, I'd have 2016 to 2013. 2016 is 85%. And in 2013, it's 60%. So that's going to be 25% over 3. 3. That's it. And what are the units? Percentages per year. That's it. Okay. What is the coefficient of this binomial expansion? Go to the 7th row, Pascal's triangle. There it is. Okay. So we have 1, 7, 21, 35, 35, 21, 7, and 1. Start out with 2x to the 7th, 2x to the 6th, 2x to the 5th, to the 4th, to the 3rd, squared, to the 1, to 0. Now we have negative 5y. Now look, they only want x to the 4th. Hone in right here. Negative 5y to the 0, negative 5y to the 1, negative 5y squared, negative 5y to the 3rd. Let's do it. 2 to the 4th is 16. Negative 5 to the 3rd is negative 125. So I just have to take, so I take my calculator. I take 35 times 16 times negative 125. Negative 70,000 x to the 4th, y to the 3rd. There it is. And we're done. Okay, I'll do the other ones later. Hey, my phone's not on silent. I get text, but I wasn't getting your call. I didn't hear anything on the call. Sorry. I'm working on my review video, so I'm sorry I didn't get it back to you sooner here. What's up? How did it go? Oh, yeah, that'd be great. Yeah. Yeah, that'd be great. That'd be awesome. Yeah. Nope, I think that's it. Are you're gonna, you have, he doesn't want to go? Because his girl won't be there.